In this video, we're going to talk about a very fascinating topic that relates to the composition of all the baryonic matter that we see, and that is the origin of the chemical elements that we see on the periodic table. On Earth, we know 118 elements, from which 90 are natural, and we're going to focus on the origin of those 90. Let's start by asking, do you know where those elements come from, and why are they in the quantities that we observe? Well, the answer to this fundamental question is fascinating, and you don't really have to be a chemistry enthusiast to like the answer. All you need to like is some astrophysics in general. In order to get to the bottom of this, we have to go back to the origin of the universe itself. The most accepted theory that we have is the Big Bang, which states that there was an event in which all matter, space, and time were created as we know it. And we can see evidence of it in many ways, such as the abundance of light elements that we measure. In the first seconds after the Big Bang, the universe was so hot and dense that not even stable nuclei were able to form. While the universe grew and got colder, a soup of particles emerged, filled with quarks, gluons, and other fundamental particles. After around 1 minute, quarks got together to form protons and neutrons. During the first 3 minutes, the cosmic chemistry mixed protons and neutrons to form the first atomic nuclei. It was here where the first light elements different from hydrogen were formed by nuclear fusion. Once the universe was able to cool down under the fusion limit, no element heavier than beryllium was able to form. So, as a result of the Big Bang, the universe was filled with hydrogen, helium, lithium, and beryllium. Okay, so this is for light elements. But what about the heavier ones? We know that the periodic table is filled with other elements that are much heavier, which means they have more protons and neutrons. This is where stars come to the game, because these elements are formed by nuclear fusion in the course of these stars. You see, hydrogen fuses to form helium, and there are other series of reactions that can form carbon, nitrogen, and oxygen in the so-called CNO cycle. Successive fusion events in different layers of the star form heavier elements, such as oxygen, sulfur, silicon, and eventually iron. But iron is the heaviest element that can be created through nuclear fusion in a star. So where do the other heavy elements come from? Stars don't really have enough energy to create those elements. Those we use for atomic bombs or in heavy industry. And here's where the story becomes much more interesting. Iron nuclei is very special because it's the most stable nuclei of all the periodic table. When this stage is reached, energy cannot be emitted, but it's absorbed, and the nucleus of the star implodes. Some heavy stars go to the stage of white dwarf, some other stars go to the stage of neutron star, and in the most extreme cases you can get a black hole. So when the external layers fall into the nuclei, they rebound in a huge explosion of particles and light. In a matter of seconds, the supernova is able to create more energy than the sun creates in its entire lifetime. These events are beautiful and they're very powerful. While iron nuclei is destroyed during the process, many neutrons are released, and because of the extreme heat conditions, these neutrons can be used to produce more elements that are much heavier than iron in processes such as neutron capture. So basically all these very heavy elements come from supernovae. These heavy elements are spread out through the universe, and those are the ones we find on Earth. They come from supernovae. In conclusion, except for man-made elements, all the elements in the periodic table come from life and death of stars. And this is why you can truly say that we're nothing but stardust, and everything you see, including the ingredients of life, come from beautiful events that happen in the universe and that we are privileged to see with our observations.